Hi everyone, this is Dr. Swaminathan SM. Now I am going to discuss about the topic recurrent neural networks under the deep learning unit. So first the recap and next introduction about the recurrent neural networks, that is why we are using the recurrent neural networks. Next, TensorFlow code, that is based on the three types: declaration, initialization and execution. RNN architecture that based three types. One is three-dimensional size, one is batch size, and second one number of steps, and third one number of features. And following with the example, we will discuss about the data representation. And next, the rolled version of RNN activity. Following with the activity, we will discuss about the unrolled version of RNN and processing a batch, a single input and execution process, and two lines of code. Following with this, we will summarize the conclusion. So first, what about the recurrent neural networks? So first, when we discuss about the neural networks, the first point comes to our mind is human brain. So the reason that is, for example, we cannot remember anything based on the humans learning. So first of all, whatever we need to learn, that is everything is stored in the human brain. So the each iteration we cannot remember, that is before the iteration, when you are processing the current set of data, it is very much needed. So we need to maintain the state register wise. So these are all the big disadvantages while identifying the correlation of the data pattern. So if you are using this RNN, it is very much useful. So the architecture designed to model the memory units, and it enable them to persist the data, thus being able to model short-term dependencies. So we will use the recurrent neural network. So this is the purpose we are using the recurrent neural networks. So the two lines of TensorFlow code that is responsible for, first one is cell. So cell is nothing but that differentiation, that is the declaration like tf dot contribute dot rnn basic rnn cell. So the RNN size and the activation it is needed based on the variable. And next the second one is state, that is tf.nn neural networks dot dynamic rnn cell inputs and a type, which data type, that is a floating point, arithmetic, or integer or short integer or anything. Here we define float 32 bits. And next, the RNN architecture, it is defined the three important dimensions. One is batch size, and second one is number of steps, and third one is number of features. So it is based on the RNN unit. The TensorFlow is called the RNN individual cell, RNN cell. So the stakeover it is called the RNN cell for one single cell or the whole layer. So this is the RNN architecture. So we need to recurrent, that is feeding itself. So recurrent means feeding itself. So it is comprised the RNN cell based on the number of steps, and it's mainly defined to model the short-term dependencies because of the hidden state of the RNN. So there are so many states we are using. One is input state, and middle state is called hidden state. So inside the hidden state, there are so many rolling or unrolling the RNN units it have. And next, last one is the output state. So the process it helps to retain the information whatever we saw, that is done in the RNN cell based on the weights and the biases. And next, the following with the example, say your batch size is 6 and RNN size is 7. So the input line is 5, means the TensorFlow shape one batch, that is 6 5 3. So these are all the example for the notation to implement or represent the recurrent neural networks. And this is the data representation in the batch of data. So there are so many data are inside, 1 2 3, like up to 1 2 3 to 18 19 20. So these are the representation of recurrent neural networks. And next to the data segmentation, it is based on the output and the input batch. In between, it is having the RNN cell. So based on the cell state, it maintains the previous state or next state or present state. This is called the rolled version. So the sliding window approach, it is used to done the time series analysis to prepare the data pre-processing, and whenever it is needed, we need to feed the data into RNN cell. Again, it will roll the architecture to the output or input. So based on the input, it is again given to the cell state. So the cell state maintains the previous state or present state or next state, and it is given to the output. So again, if it is needed to reorganize the data, means again the cell state is given to the reorganized version. So it is called the rolled version of the RNN. And next, following with the activity, we will discuss about the unrolled version. So here the unrolled version, we are feeding the input shape like 1 2 3, and the output shape will be the 1 comma 7. That means 1 to 7 inputs. So the initial hidden state, that is vector length, may be 7, means we need to discuss about the 7 cells. So from input to output, in between, it is having the RNN unrolled unit. So the processing of the data, that means first when you feed the batch of data to the RNN cell, it starts the processing if the first line of the input. So likewise, it is sequentially it feed the data, and based on the data, it is rolling or unrolling. It may be happened. So this is the processing of the single line input based on the RNN cell and the number of steps and the number of times. So based on the previous figure. And next, the execution that done based on this hidden state time input st f, that is iw, that forward 1 2 3 plus ib and plus hw plus s initial state plus hb is nothing but biasing. So the biasing hidden state weight, that is called h, and s is nothing but hidden state, and input weight is nothing but, that is the I. And next, the recurrent neural networks, it is defined the output, that is STOW. O is nothing but output weight, and OB is nothing but the output biasing. So the hidden state calculation time input, that is ST plus 1, that is next state may be F, and IW plus 4 5 6, that is output state, and next HW ST plus HB, that is based on the typical turn H, that is called F, and the input weight is nothing but I. So the time step may be Ti plus 1, that is first current state may be Ti plus 1, means that is next state. Ti minus 1 means that is the previous state. So to obtain the Ti plus 1, that output calculation, that may be the St plus 1 OW plus OB. So O is nothing but the output weight, O for output weight. So each and every term, whatever it is traveled from input to output through the hidden state, it is having the output weight. So this process will repeat all the time steps, and again the processing the 5 outputs, means we shape the 1 comma 7. So same like 157, and output may be the 657. So all the hidden state weight and output weight have the same value throughout all the connections of the RNN. And next to the cell, it is defined the cell and state based on this first and second line. So the first line defines the activation function of the RNN cell, RNN size and RNN cell, whatever we want to create. And the second line, it may be the executes the processing procedures of the input data by feeding it to the RNN. So that is as to cell and state. So these are all the assessment and thank you. We discussed about the data manipulation and representation, that is process of the RNN in a tensor flow. So this is called the recurrent neural networks. Thank you.